The first telescope was planned by Hans Lippershey in 1608. Galileo then improved on the design with 20 times the magnifying power to observe the cosmos and was the first to point it at space. Later, Newton was able to replace the lens in the telescope with a mirror, which allowed for no more chromatic aberration, a wider view, and made it more portable. The first huge telescope was made in 1789 and was 12 meters long. During the 1800s, the giant telescopes continued to rise, and most were made with mirrors of at least 9 meters long. The giant Magellan telescope had 7 mirrors. The image will reflect off the 7 primary mirrors and then again off the smaller secondary mirrors to the charge-coupled device. The device then will measure concentrated light to determine how far away the object is and what it is made of.
Bigger is better for telescope mirrors, but bigger mirrors collapse under their own weight. That is why thin and lightweight materials are essential. So with new discoveries in technology, mirrors have been able to get thinner, lighter, and bigger. To do this, the mirrors in the Magellan telescope are made of borosilicate glass coated in a thin layer of aluminum silica fibers only a few atoms thick. The shape of the aluminum coating is important so it can capture every photon of light it can.
We are now focusing on the aluminum composition. It is one of the most abundant metals on Earth's crust at around 8.2%. There is suspicion of the material as early as 1781, but there is no ability to extract it until 1825. Aluminum can be found in everyday life. It is used in things like insulation, kitchenware, and other houseware. For example, aluminum insulators in windows, aluminum foil wrapping your lunch, pots and pans, even many deodorants have aluminum. There's a use every day and sometimes we don't even realize it. Some bigger applications of aluminum are airplane parts and electric power lines. So, with all these applications, there are commercial and economic impacts of common usage, which leads to supply and demand. Job creation is another impact, as people are needed to make the supply. And the people with demand can then help Earth by recycling the aluminum so it can be reused once again.
Aluminum does not occur naturally. Thus, we need to mine bauxite ore, which contains 17% alumina. This alumina is chemically extracted from bauxite ore, and then it is dissolved in a molten cryolite bath in a steel pot. Carbon anodes and electric current is added to the bath. This allows the oxygen to bind to the carbon, leaving molten aluminum at the bottom. With this process, 4 pounds of bauxite creates 2 pounds of alumina, and then 2 pounds of alumina creates 1 pound of aluminum. So, 4 pounds of bauxite actually creates only 1 pound of aluminum.
Other metals can be used for coating mirrors, but aluminum is a good choice due to its unique properties. It is stable, lightweight, durable, resistant to scratches, and can be manufactured to be very thin. It is also one of the most reflective of metals, as it reflects 92% of visible light as well as 98% of infrared rays. It is also useful in some other of its properties, as it is 100% recyclable and is unaffected by UV light.
In the process of refining and smelting aluminum, there are greenhouse gas emissions. The gases created are perfluorocarbons, polycyclic aromatic hydrocarbons, fluoride, sulfur dioxide, carbon dioxide, and occasionally acid rain. The most potent gas is perfluorocarbon. Production of aluminum is the leading PFC generator in the U.S. To reduce emissions, aluminum can be recycled. Scraps of aluminum only require 5% of the initial energy compared to the creation of aluminum. Scraps can come from automobiles, building materials, and appliances. Recycling aluminum does not affect the quality of it, thus, aluminum can be continuously recycled.